Hi, my name is Jonathan Charles, and welcome to Examining the Cisco SD WAN Architecture, Components, and Functions. So we're going to review the SD WAN solution components and functions, introducing in the course the SD WAN operations and development. After we're done with this, you're going to be able to describe how the WAN is evolving with software-defined networking. And we're going to describe about all those Cisco SD WAN components and their functions. So the WAN isn't as simple as it used to be. We can no longer rely on a single provider circuit connecting our critical sites to our critical applications. We're also being hit with requirements to meet the needs of a new user and network dynamic. We have new security and latency requirements due to compliance and wide-scale adoption of interactive voice and video. A lot of services are going to be moving to the cloud, and providing just one internet connection to a site is not going to meet the needs of our users as they attempt to connect to those new cloud deployed services. That's software as a service, Office 365, CRM applications, hosted voice, etc. A single MPLS network in a hub and spoke environment just doesn't explain the way networks are used anymore. Having a point-to-point circuit back to a head-end site and providing internet access from there will not provide the bandwidth required as applications are moved to the cloud and data centers are being scaled back and virtualized. There's no reason we should have to rely on a single internet connection and then suffer outages when a backhoe finds your fiber. So the Cisco SD WAN solution is software-based. It's a virtual IP fabric network that builds a secure, unified connectivity over any transport network, the underlay. We're going to talk about this a lot. The underlay network is the physical infrastructure for the WAN, such as the internet, MPLS, Metro Ethernet, your 4G network. The underlay network provides a service to the overlay network and is responsible for the delivery of packets across networks. We're going to use these terms underlay and overlay a lot. Keep them in mind as we proceed through this course. The underlay network, as you see here below, is the infrastructure that you have now. All right? The overlay network is the SD WAN solution that we're going to run on top of that underlay network. The whole point here is that SD WAN is on top of those existing WAN links and low-cost internet connections, and then we can aggregate them together and use the most reliable method to move data between sites. The Cisco SD WAN is based on the same routing principles used on the internet for years. So don't panic. If you know how OSPF, BGP, and NAT work, they still do. The goal here is to separate the data plane from the control plane, and then we'll virtualize much of the routing that used to require dedicated hardware. This separation between control and data plane enables the SD WAN solution to run over any transport circuits. If you can ping it, we can build a tunnel across it. As long as you have connectivity between sites, MPLS, internet, a point-to-point link, whatever, we can create tunnels between sites and then engineer the traffic to use those tunnels efficiently. The virtual network runs as an overlay on cost-effective hardware. So the overlay is going to be running over this system. Whether they are physical routers called V-Edge routers, these guys here are V-Edge routers. Actually, all of them are. We have vCloud routers, which is basically a virtualized router, so the V-Edge cloud router. Or if we running V-Edge software on an existing Cisco ISR 4000 series router. Centralized controllers called vSmart controllers oversee the control plane of the SD-WAN fabric, efficiently managing, provisioning, maintaining, and providing security for the entire SD-WAN overlay network. The vBond orchestrator automatically authenticates all other SD-WAN devices when they join the SD-WAN overlay network. To remember what the vBond does, basically think of the V-Edge as coming up and then bonding with the vBond to find the services in their environment. The control plane manages the rules for the routing traffic through the overlay network. And the data plane passes the actual data packets among the network devices. The control plane and data plane form the fabric for each customer's deployment according to their requirements over their currently existing circuits. The vManaged Network Management System, NMS, provides a simple yet powerful set of graphical dashboards for monitoring network performance on all devices in the overlay network from a centralized monitoring station, and provides a single pane of glass into the entire solution. In addition, the vManaged NMS provides centralized software installation upgrades and provisioning, whether for a single device or as a bulk operation for many devices simultaneously. The vBond orchestrator facilitates the initial bring up by performing authentication and authorization of all elements in the network. Cisco vBond orchestrator also provides the information on how each of the components connects to all the other components. vBond orchestrator plays an important role in facilitating Cisco SD WAN devices that sit behind the network address translation to communicate with the network. If you sit behind that, vBond is the device that makes it possible to communicate with the network and from the overlay. When a vEdge device comes up, it bonds the network via vBond. Each vEdge has a built-in hardware certificate that authenticates it to vBond, so when it comes up, it's already trusted. The Cisco vBond orchestrator is a multi-tenant element of the Cisco SD WAN fabric and is the first point of contact and performs initial authentication when devices are connecting to the organizational overlay. vBond facilitates the mutual discovery of the controller and management elements of the fabric by using a zero trust certificate-based allowed list model. Cisco vBond automatically distributes a list of vSmart controllers and the vManage system to the vEdge routers during the deployment process. So when you come up, you connect to vBond, and then vBond tells you where the vSmarts are and the vManages. If your vSmart controllers or vManager behind NAT, vBond will enable NAT traversal to secure communications. Discovery of a public and private IP address allows connectivity to be established across public, internet, 4G, and private, MPLS or point-to-point, WAN transports. The vBond orchestrator itself has to reside in the public IP space or in the private IP space with a one-to-one NAT, so that all remote, especially internet-only sites, can reach it. It also needs to be highly resilient. If vBond is down, no other device can join the overlay. When deployed as an on-premise solution by the customer, it's the responsibility of the customer to provide adequate infrastructure resiliency. And we can run this in single or multi-tenant mode. The entire solution is going to be managed by Cisco vManage, which provides a single pane of glass, centralized management, and provisioning platform for day 0, day 1, and beyond for the entire SD-WAN infrastructure. It has a web-based GUI with role-based access control. Some key functions of Cisco vManage include centralized provisioning, centralized policies, and device configuration templates, and the ability to troubleshoot and monitor the entire environment. You can also perform centralized software upgrades on all fabric elements, which include vEdges, vBond, vSmart, and vManage itself. vManage should also run in high resiliency mode because if you lose vManage, you lose your management plane. vManage supports multi-tenant mode as well, in addition to the default single-tenant mode of operation. vSmart controllers are the centralized brain of the solution that implements policies and connectivity between SD-WAN branches. The centralized policy engine in Cisco vSmart controllers provides policy constructs to manipulate routing information, access control, segmentation, extranets, and service chaining. vSmart controllers are scale-out control plane functions of the Cisco SD-WAN fabric. They facilitate fabric discovery by running the overlay management protocol among themselves and between themselves and the vEdge routers. Together with vEdge routers, vSmart controllers act as a distribution system for the pertinent information required to establish the data plane connectivity directly between the vEdge routers. This information includes service, LAN side reachability, transport, WAN side, IP addressing, IPsec encryption keys, site identifiers, and so on. All control plane updates are sent from vEdges to vSmart in a route reflector fashion. vSmart then reflects those updates to all remote vEdge sites. So when vSmart receives an update from a vEdge device, it then distributes it down to each of the other devices. This is how every vEdge learns about all available tunnel endpoints and user prefixes in the network without full mesh routing updates. Because the control plane is centralized, you're not required to build control plane channels between all of vEdge's devices directly. vSmart controllers also distribute data plane and application-aware routing policies to the vEdge routers for enforcement. Control policies, acting on the control plane information, are locally enforced on the vSmart controllers. These control plane policies can implement service chaining and various types of topologies, and generally can influence the flow of traffic across the fabric. The use of a centralized control plane dramatically reduces the control plane load traditionally associated with building large-scale IPsec networks, solving the n-squared complexity problem, aka full mesh. The vSmart controller deployment model not only solves the horizontal scale issue, but also provides high availability and redundancy. vSmart controllers are often deployed in geographically dispersed data centers to even further reduce the likelihood of control plane failure. When delivered as a cloud service, vSmart controllers are redundantly hosted in the Cisco cloud. When deployed as an on-premises solution by the customer can provide infrastructure resiliency. Cisco vEdge routers are the data plane elements of the Cisco SD WAN fabric. They are, in essence, WAN edge routers that are positioned everywhere that the SD WAN fabric must be extended to. If you want to participate in the SD WAN fabric, you need a vEdge device, and they're going to be sized based on your needed bandwidth. vEdge routers are responsible for encrypting and decrypting applications between the sites. As mentioned earlier, vEdge routers establish a control plane relationship with the vSmart controllers to exchange pertinent information that is required to establish the fabric and learn centrally provisioned policies. Data plane and application-aware routing policies are implemented on the vEdge routers. vEdge routers export performance statistics as well as alerts and events to the centralized vManage system for a single point of management. vEdge routers use standards-based OSPF and BGP routing protocols for learning reachability information from service-side interfaces and for brownfield integration with non-SD-WAN sites. vEdge routers have a very mature full-stack routing implementation which accommodates simple, moderate, and complex routed environments. For layer 2 redundancy, the service-side LAN interfaces, vEdge routers implement VRRP, first hop redundancy protocol, which can operate on a per VLAN basis. vEdge routers can be brought online in a full zero-touch deployment fashion or by requiring administrative approval. Zero-touch deployment relies on the use of a digitally signed certificate installed on the onboard tamper-proof module to establish a unique router identity. Finally, vEdge routers are delivered in both physical and virtual form factors. Physical form factors are deployed as appliances with 100 meg, 1 gig, or 10 gig interfaces based on the throughput needs. The virtual form factor can be deployed in public clouds such as Amazon Web Services, Microsoft Azure, or as a network function virtualization on the virtual customer premises equipment platforms with the use of KVM or ESXi hypervisors. We also provide the REST API, which is a programmatic interface for controlling, configuring, and monitoring the Cisco SD WAN devices in an overlay network. You can access the API through the vManage web server. A REST API is a web service API that adheres to the REST, or representational state transfer architecture. The REST architecture uses a stateless client-server cacheable communication protocol. The vManage MMS web server uses HTTP and a secure counterpart HTTPS as a communications protocol. REST applications communicate over HTTP or HTTPS by using standard HTTP methods to make calls between network devices. vAnalytics provides graphical representations of the performance of your entire SD-WAN overlay network over time and enables you to drill down to the characteristics of a single carrier, tunnel, or application at a particular time. The vAnalytics dashboard serves as an interactive overview of your network and entrance points for more details. This dashboard displays information for the last 24 hours. When you drill down, you can select various time periods for which to display data. The vAnalytics platform calculates virtual quality of experience based on latency, loss, jitter, or any customized calculations for each application you have. Some vAnalytic features are as follows. We can provide real-time information for failure correlation, cross-customer benchmarking, and application performance scores. We can also enable future planning based on intelligent data, applications and bandwidth forecasting, branch expansion analysis, and policy change what-ifs. We can provide a quality of experience score in applications that are running on your network to help identify how your application is performing based on recent changes made to your network. So in summary, SD-WAN represents a shift from an older, hardware-based model of legacy WAN to a secure, software-based virtual IP fabric overlay that runs over standard network transport services. This solution includes the vBond orchestrator on the orchestration layer, vManage NMS on the management plane, vSmart controller on the control plane, and vEdge devices on the data plane. Thank you for watching, and stay tuned for more SD WAN content.